next concept is a remainder theorem. Till now, we've been doing about the factors, so there were no remainders. For example, we divide 8 by 2, which is exactly divisible by 4, exactly divisible by 2 4 times. And 0 is the proof that 4 is a factor. And when we divide 7 by 2, 2 3 times is 6, 1 is left. So this is the quotient, dividend, divisor, and remainder. So we are going for a remainder theorem in this section now. So let's just do this solved example. This is 2x cube minus 4x square plus 7x minus 37. X is equals to 3. Factor theorem that is already done. When x is 3, we can see that the remainder is 2. And if we go for long division, x is equals to 3 would mean we are dividing it with x minus 3. So to get 2x cube, I'm multiplying it with 2x square. So this is 2x cube. 3 2 times is minus 6x square. Sign changes, and this is 4 and 6. 10x square plus 7x minus 37. To get 10x square, we multiply with 10x. That's 10x square. 3 into 10 is minus 30x plus 2 minus 2 plus. Get rid of this, and this is 37x minus 37. Did something wrong? Oh yeah. No.
13 was
Oh, yeah.
39.
That was like I just used these two as 10 minus 4 and 6. Minus 4 and plus 6. This is plus 2x square. And 2x square multiply with 2x. 2 3 is 6. Plus 2 minus 2 plus. And this is 6 is 12 and 13x minus 37. And now we go for 13. So x into 13 is 13x minus 39. Change the sign, and 2. So this is the remainder. And we stop here, like we know that 2 could not be divided with x.
And so in a question, we would just write beside our answer, we would write remainder too.
Yes.
Okay.
Okay. It says find the remainder when these are divided. So in this case, Question 1a. It is not given that by which method x cube plus 2x square minus x plus 3. When it is divided by x minus 1, x is equals to 1. So I could use factor theorem. Plus 2 into 1 square minus 1 plus 3. It's 1, 2 minus 1, 3. The remainder is 5. F of x is equals to x cube minus 6x square plus 11x minus 7. When it is divided by x minus 2, that means x is equals to 2. F of 2 is equals to 2 cube minus 6 into 2 square plus 11 into 2 minus 7. 2 cube is 8. 6 4 times 24, 22 and minus 7. Using calculator, 8 minus 24 plus 22 minus 7, getting minus 1. This is the remainder. Try D part.
D.
D doctor.
Two.
Correct. X is equals to 1 by 2. Substitute 1 by 2. Get plus 2. Now question number 2, it says find when this is divided by x minus 1, the remainder is 5. This is different type of question. We'll try it with both methods. F of x is equals to x cube plus x square plus ax minus 2. And when it is divisible by x minus 1, the remainder is 5. So dividing by x minus 1 would mean value of x is 1. 1 cube plus 1 square plus a into 1 minus 2. Remainder is 5. That's 1, 1, a, and 2. So minus 2 and plus 2 cancels out. A is equals to 5. X cube plus x square plus 3x minus 2 when divided by x minus 1. First step is x square. X into x is x cube minus x square plus minus minus plus. Cancels out. That's 2x square plus ax minus 2. Now we divide. We multiply with 2x. Okay. 2x squared and minus 1, this is minus 2x. Plus 2 minus, minus 2 plus. This cancels out and we are left with a plus 2 x minus 2. So this is still divisible because that x. So in order to get that, I'm multiplying with a plus 2. So you get a plus 2 into x, and with negative sign, this is negative a, negative 2. Next step is we change the sign. So we cancel out minus 2 and plus 2 cancel out. I'm left with only a, and the remainder is already given. So whatever is remaining is equal to the remainder.
It seems like the second method is a bit more complicated, but in the actual exam, will it matter which method we use?
Now that's actually fine. Both are equal weighted, and if not restricted, we will or always go for method 1.
Okay.
That's much simpler and quick. And the results are same. B part says 2x cube minus 6x square plus 7x plus b divided by x minus 2. The remainder is 3. Now let's punch that in directly. When it is divided by x plus 2 means the value of x is minus 2. So 2 into minus 2 cube minus x into minus 2 square,
Excuse me, can you hear me?
and the remainder equals to.
Hello?
Yeah, sure.
Can you hear me right now?
I can hear you.
Okay. Could you repeat your question, please?
There was no question. I was saying we'll substitute it directly.
Oh, okay.
So when it is divided by x plus 2, the value of x is minus 2 and the remainder is 3. So substituted minus 2 directly and equated it with 3. Now I'm using calculator for left hand side. 2 into minus 2 cube minus 6 into minus 2 square plus 7 into minus 2, getting negative 54. So p is equals to 3 plus 54. P is equals to 57. Try C part. 2x cube plus x square plus cx minus 10. And when it is divided by 2x minus 1, the remainder is minus 4.
C equals negative 1.4.
Negative 1.4. I guess I'm getting 11. So it says it is divisible by 2x minus 1 means value of x is 1 by 2. 1 by 2 cube, 1 by 2 square, c to 1 by 2 minus 10 is equals to minus 4. So 2 into 1 by 8 plus 1 by 4 minus 10 is negative 9.5 plus e by 2 is equal to minus 4. 9.5 minus 4 is 5.5. C is equals to P.
Oh, I messed up on that last part. I think I messed up with the values. Instead of dividing it by 2, multiplying it 5.5 by 2, I divided it by negative 4. That's the part I messed up.
Yeah. So that's 11. Now the difficulty level of the question is slightly increasing. The concept is exactly same. See, there are two unknowns this time. It says f of x has a factor of minus 1 and leaves a remainder of 3. Just extracting the information. X cube plus ax square plus bx minus 5. X minus 1 equals to 0 and leaves a remainder of 3. And when divided by x plus 2, f of x has factor of x minus 1 and leaves a remainder of 3 when divided by x plus 2. So the first part is the factor and second part leaves the remainder of 3. So we have these two informations to carry on. So firstly, when it is a remainder, that would mean 0 is equals to value of x is 1 at that time. 1 cube plus a to 1 square plus b to 1 minus 5. So 0 is equals to 1 plus a plus b minus 5. 1 minus 5 is minus 4. A plus b is equals to 4 is equation 1. Or the second part, when x plus 2x is equals to minus 2. So minus 2 cube a into minus 2 square b into minus 2 minus 5 is equals to the remainder is 3. Minus 8 plus 4a minus 2b minus 5 is equals to 8 and 5 is 13. Minus 13 goes on other side, becomes plus 13. 4a minus 2b is equals to 16. 2a minus b is equals to 8. This is equation 2. I can see we can just add them to get the values. 2a minus b is equal to 8 and a plus b is equals to 4. So when we just add them, that's 3a is equals to 12. A is equals to 12 by 3. A is equals to 4. When a is 4, we can use any equation. B is equals to 0. Try number 4.
In our first equation, we're allowed to have two whole numbers, right? Because in the other one that we were doing was a plus b equals 4. So would something like 4a plus b equals -30 be allowed as a first equation?
Are you talking about the simultaneous equations you made?
Yeah,
Yeah, we could have any numbers.
okay.
For now, I'm getting this as first equation. 4a plus b equals -30.
Yes, I'm getting the same thing. A and b are both -6.
It's -6. Okay, let's find something different. And I guess 5 is different. It says f of x as factor of x minus 3 and leaves the remainder of 15 when divided by x plus 5. Here the remainder is 0. It is 15 when divided by x plus 2. First we find a and b and then we solve the cubic equation. F of x is equals to x cubed minus 2x square plus ax plus b. So firstly it has a factor x minus 3, so value of x is 3. Three a plus b equal to -9. And second when x is -2, remainder is 15. plus 16 is 31. It's a quotient. A plus B equals minus 9 minus 2A plus B is equal to 31. And subtracting it, 5A and that's 40 is equal to minus 8 minus 2A plus B is equal to 31 minus 2 to minus 8 is 31 into 16. 16 f of x is x cubed minus 2x square and a is minus 8x and b is 15. And b part says solve this equal to 0. We already know as a factor of x minus 3. X cubed minus 2x square minus 8x plus 15, and it has a factor of x plus 3, x minus 3. X into x square is x cubed minus 3x square, sign changes, x square minus 8x plus 15. With x, we get x square minus 3x minus 5x plus 15. So with minus 5, we get minus 5x plus 15 and 0. X minus 3 into x square plus x minus 5. Where we know the first is already known. Second is x square plus x minus 5 equal to 0. I cannot think of the factors for 1 and 5. I'm going for quadratic formula. Minus b plus minus square root b square minus 4ac equal to a. Minus 1 plus minus 4 plus 15, 21, 2. X is equals to minus 1 plus square root 21 by 2. X is equals to minus 1 plus square root negative minus square root 21. First is already. So these are the three values. When this is divided, f of x has a factor of this and leaves a remainder of 48 when divided by this. Find values of a and b, find the remainder when this is divisible by x minus 1. I think it's in that for now. Because we know how to do the first part. Then for the second part, when that's done, we substitute a and b and just use x is equals to 1 and state what is the limit. Where
Yeah, so basically we just find the values like we did before, A and B, and then we divide it by x minus 1 with the values of A and B, right? Okay.
f of x is there, did and remained dead. I did remain dead. One of my is given them just about his friends. Let's try number 10. That seems a little.
Which question?
Number 10.
Okay.
Have we recorded the question? We have three unknowns.
So 10 is the one at top, x squared, x cubed plus ax squared.
Yes.
Okay. Sorry, so the first thing you did was you plugged in the 0 because it said that the root of f of x is 0. And then we got c equals 0.
Yes.
And then afterwards, the two equations that we had, it was 2 and 3. And then so k is just another factor?
Yes.
Okay. And then from knowing a and b, we would be able to know k, right?
Yes. With the information given that K is effective.
and then plus 0, so we don't have to put c.
Yeah, no need. Are we getting the same? X cube minus x square minus xx.
Oh, I was kind of looking at what you were doing because I was kind of confused with the question, but I understand what you did.
Okay. So now it is also given that the root is k. So we could just substitute k, f of k equals to k cube minus k square minus xk. And this is k cube minus k square minus 6k is equals to 0. K could be taken out common and written as k square minus k minus 6 is equals to 0. K is equals to 0, which is definitely the first one when x is 0. So 0, 2, and 3, other than that, whatever we get. And this is 0, 2, 3. I guess we'll get same values. This is k square minus 6 minus k minus 6 is equals to 0. K square minus 3k plus 2k minus 6. K common. K minus 3 plus 2 common. K minus 3. K plus 2 into k minus 3. K plus 2 equals to 0. K is equals to minus 2. K minus 3 is equal to 0. K is equals to 3. So 3 is already there. 0 is already there. So the new number is minus 2. Therefore, k is equals to minus 2. If I want to have substituted k first, let those all be equal to x. We would have got x is equals to 0, x is equals to minus 2, and x is equals to 3, in which this is new. K is equals to minus 2. And then it says find the remainder of f of x when it is divided by x plus 1. So we simply substitute x minus 1. F of minus 1 is minus 1 cube a cos minus 1 equals minus 6. Negative 1, negative 1 plus 6. The remainder is 4 when it is divided by x plus 1. Clear?
Yes.
Eleven is typically the same question. 12 is a bit different. Try this.
Question 12?
Yes.
Okay.
Done.
Last step.
Okay.
So k equals 32.
Yes. Look at number 13. Polynomial is given x cube plus 2x square minus 6x plus 9. When f of x is divided by x plus a, the remainder is r. When divided by x minus a, the remainder is 2r. Just like we did in 12. First we'll substitute minus a and put that equal to r, then plus a, put that equal to 2r. And ultimately we get the values of a and r by solving the simultaneous equation. And substitute that in the equation back. Show 3a cube minus 2x square minus 16a minus 9 equals to 0. And then ultimately solve the equation in parting completely. That's just a equation. First factor by hit and trial, second by long division. There's one more method.
Second by what? First by hidden trial, second by what?
We call this long division.
Oh, okay.
So far, this method. There's one method of the synthetic division,
Okay.
a bit easier than long division. I'll didn't introduce it, then just later on to the second. Number 40 is again the same. Let's try 15. Says the polynomial p of x is equals to 5 into x minus 1 minus 2 minus 3 plus a into x minus 1 minus 2 b into x minus 1 c. A, b, and c, three unknowns. It is given that p of x is divided by each of x minus 1 minus 2 minus 3. The remainder are 7, 2, and 1. So it is just one lengthy question, nothing else. Let's just do it. Question 15. P of x is equals to 5 into x minus 1, x minus 2, x minus 3 plus a into x minus 1, x minus 2 plus b into x minus 1. Last is c. And it is given when it is divided by x minus 1, x minus 2, and x minus 3. The remainders are 7, 2, and 1. 7, 2, and 1.
So could we just, like, let's say divide it by x minus 1, and then what's left is equal to 7?
Yes. See, when we use this, value of x is 1. So p of 1, we had directly substitute this complete thing as 0. Because when we are substituting x1 first bracket, that becomes 0. This one.
Yeah, and then it's multiplied to the others.
And again, second one is 0. And again, third one is 0. So plus c is equals to 7. C done. Now when we use x minus 2, that means x is 2. So p of 2 is equals to, again, first part becomes 0. Because of this x minus 2 with a becomes 0. p into 2 minus 1 plus c. 2 minus 1, or should just replace it with the known value 7. 2 minus 1 is 1. So p plus 7 is equals to 2. P is equals to 2 minus 7. P is equals to minus 5. And the third one, when x is minus 3, p of 3 is equals to, because of this minus 3, this is again 0. We have now different value plus a into 3 minus 1, 3 minus 2, b is already there, minus 5, d minus 1, c is already there, that's 7. And the remainder was 1 divided, this is 1. 1 is equals to a into 3 minus 1 is 2, 3 minus 2 is 1, 3 minus 1 is 2, 5 times minus 10 plus 7, that's 2a, and 7 minus 10 is minus 3, goes on the other side, 4a is equals to 2. a2, b minus 5, and c is equals to 7. See if there was